Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have this double integral. We have to sketch the region whose area is given by this double integral. Then we have to change the order of the integration. And then finally, we have to show that both orders will give us the same value because they should give us the area of the same region. Okay, so let's consider the integral, the double integral as it is and see if we can figure out which region it represents. Okay, so the first one we have 0 to 1, 2y to 2 dx dy. Okay, so we have the bounds right here. See, the outer function, the outer variable is dy, and therefore the bounds for y are 0 and 1. And the inner one is dx, so its bounds are 2y and 2. All right, so if we want to graph, let's see what functions we see. So first one, I can see right away here we have a function. X is between 2y and 2. So x equals 2y, that's a line, and the graph should be there, right? So what line is it? It's y equals x over 2, if you want to think of it in the other way. So let's try to graph that first. So this is same as y equals x over 2. So that means it passes through origin, because x equals 0 will give you y equals 0, and x equals 2 will give you y equals 1. So let's see. Let's say this is 1 and 2, and then here we have 1. So here is our line, x equals 2y. Okay, now let's see. X is between 2y and 2, and y is between 0 and 1. So what region is that? To understand it better, we can consider a representing rectangle. Now, remember how to draw the rectangle. Look here. Since y is the outer variable, so rectangle should be drawn horizontally. Okay, so if we draw the rectangle horizontally inside the region here, makes sense, right? X is between 2y, this graph, and 2, and y is between, this is delta y, so y is between 0 and 1. So our region is this region, whose area can be computed using this double integral. Okay, so that's the first part of the problem. Now we have to change the order of integration and figure out how we can change the order to get the same area, right? So let's say this was part A, and now part B, we change the order. Okay, so to change the order, that means we need to write it as dy and then dx. So x is our outer variable, right? Now since we already know what our region will look like, so we can just draw the region one more time. roughly. And this line is x equals 2y. Let me rewrite it as y equals x over 2 because I know I will have to change the order. So, I will need it written this way. And changing order means changing this rectangle as well. Instead of horizontal, now we have to draw a vertical rectangle. So, let us say the rectangle is right here. That is our representing because it is the same region, right? And so, we have delta x as the width. So, let us just look at what are the bounds of x and y. So, I know that this is 2, right? So, x bounds are, so x is from 0 to 2 and y is the length of the rectangle. So, from x axis to the line, so y is between 0 and the line is x over 2. And therefore, the integral will be outside is x, so 0 to 2 in the outside, inside is y, which is 0 to x over 2. So, when you change the order to get the same area of the same region, this is the setup of the double integral. All right. Finally, we just have to solve them and see if we get the same answer or not. Okay. So, let us start with the first one. So, this is C. We are solving both integrals. So, we have 0 to 1, 2y to 2 dx dy. Okay. Ignore the outside integral. First, just evaluate the inside. Integral of dx is just x, and then we have to evaluate from 2y to 2. So, this is equal to, plug in 2 for x minus plug in 2y for x, so that dy. And then the antiderivative will be 2y minus 2y square over 2, and then you plug in 0 and 1. Notice that this 2 will cancel. So, you will end up having 2 minus 1 minus 0, because when you plug in 0 for both terms it will be 0. So, your answer should be just 1. So, it will be 1 square unit. Let us see if we get the same result using this other integral. Okay. So, what if we have now 0 to 2, 0 to x over 2 dy dx. All right. Keep 0 to 2 as it is. Now, the inside integral you consider, ignore the dx. Integral of dy is just y, and you evaluate from 0 to x over 2. Keep the dx as it is. Okay. So, now plug in x over 2 minus 0, which is just nothing. So, just x over 2. And then 1/2 is a constant, pull it out. Integral of x is x square over 2, and then you have to evaluate that between 0 and 2, and so you get 2 square over 2 times 2, 4, minus 0 because x equals 0 is 0, and this is just 1 again. So, we get the same value using both double integrals, which checks that we have a correct setup for the area of the same region. Thank you.